Hello guys, welcome to my YouTube tutorial, and today I'll be taking you guys electronics. Actually, I'm not fully prepared as this is my first video on YouTube, and I would like you guys to bear it with me any inconveniences. So um, this is not actually basic electronics that we are doing today. I just finished the project, the AutoSurge 100. It's an automatic changeover and surge protector. So I would like to share with you guys for anyone who is interested in making that kind of project. And today is not the practical aspect. We'll be doing the simulation with our proteus, and after today's video, maybe the next video, we'll do the practical aspect of the circuit. And to make this video easier to follow for you guys and simple for you guys, it will be too much tasky or too much long to make this kind of project in a single video, and I feel I should break this video into parts, into chunks, so that it will be easier for us to follow up. And the first part that we'll be doing today is the ADC circuit, the analog to digital converter circuit. For anyone who knows about power electronics before, this kind of common topic that everybody should know. But for anyone who is just starting with electronics, ADC is a analog to digital converter circuit, and it is very useful in power electronics. So that's what we are going to be doing today. So ADC is let me just explain. When dealing with ICs or any other integrated circuit that you feel it works with only DC, and for example, you want to measure your AC voltage, higher AC voltage. For example, I'm staying here in Nigeria, we are using 220 voltage, that's our nominal voltage. It is very impossible to measure that kind of voltage with an IC, with a microcontroller or any other IC that I want to use. It's very impossible. So this is what we are going to be doing. We are going to reduce the voltage into smaller DC voltage that is readable and tolerable for our IC. So that's what we are going to be doing. That's basically what ADC means, analog to digital converter circuits. We are going to convert the AC to readable DC voltage for our IC, and I will compare the current AC voltage with the current DC voltage. You understand that this as time goes on, and this is what I'm going to be doing. This is proteus interface. I'm using proteus 8.13, and this is the interface. When you open it, this is what it gives you. Here in the interface, I have many things on the screen, and this is what I'm going to be doing. I'm going to be creating a project. And it's loading. Give me some seconds. Not responding. Okay, so here we have a new project. We have a PDS. This PDSP file. Okay, let me zoom this for you so that you see very well. So this actually means this is a proteus file. And we have real projects here. So here you can name it anything you want. Here I'm naming it. I will name it ADC analog. Sorry, analog to digital converter circuit. So this is what I'm going to be naming it. And we have path here. So this path actually means where do you want to store this project that I want to create. Yeah, I will leave it by default. We have documents, and this is okay by me, so I will just press next. Okay, we have new project wizard, and under this we have two options. Do not create a schematic, and the second one is create a schematic from the selected template. So I won't care about this, as any edits can be made later. So I will just press next. Okay, this is the interface of the proteus 8.13. It is very easier to use and very friendly for anyone that has been using proteus. I know this is not new. It is very easy, so we can just start our circuit. And actually this is an interface for our schematic capture, our schematic circuit. We draw a schematic here, go on our simulation here, And after that we go into PCB. This is actually where you make your PCB layout, and this is where you visualize it in 3D format. So this, we are not doing this today. We are doing this schematic, we are running it today. We want to see if it will actually work. And for anyone who is new to Proteus, okay, this is where you choose your components. This is where you choose your components. Yeah, you go here. This is where you choose your components, and you go to pick right here. So, and after choosing that, so what are you looking for? What are you looking for? What's the components you are looking for? Okay, yeah. What do you want to do? We want to convert our AC voltage into DC voltage, and doing that, what are we going to be needing as our first component? And if we look at it, we'll know that the first thing that we are going to be considering is our AC voltage. How do we get our AC source? And that's by using a component that will deliver down for us. And there are many ways to do that on Proteus, but the way that I know that I've been using is using the alternator. Alternator means alternating currents. Yeah. Okay, alternator is a device or component that will give us alternating current. Okay, from this description we can see that alternator admitted AC voltage source, and here the component picture actually tells us that this is actually what we are looking for. And this is the beautiful part of the Proteus. You will see what you are looking for. You see the schematic symbol, and this says this is what you are looking for. I'm very certain that this is what I'm going to use, since this symbol actually means this gives us an alternating current. Yeah. Okay, so I will choose this right here, which is okay. I'm going to be choosing this. Okay, so let me enlarge this for you guys to see. All right. Okay, this component gives us about alternating current. So we have to edit these properties, because by default Proteus will give us our values, but it might not be suitable for what we want it for actually. So I'm going to be double clicking on this, and you can see this option right here. We have edit components, and we have part reference, part value. Just skip that. You have elements. We have amplitude, we have frequency, we have other properties. You can just put anything you like right here. Well, don't give yourself stress. So we have frequency, which is 1 Hz here, which is actually not so in Nigeria here. We are using 50 to 60 Hz. So I'm going to be using 50 Hz. If you like, you can go with 60 Hz. It doesn't matter. And amplitude here is 6 volts, 6 voltage, and it is actually not true here. Okay, this kind of tricky, but it's something very simple to get. Here in Nigeria, we are using 220 voltage as our nominal voltage, and what we are going to be doing right here is multiply it by root 2, which is 1.414, and get our amplitude. Okay, if you multiply 220 by 1.414, we have what, 311 points. Any other thing, I don't care. So 311 is okay for me. If you are using 150 voltage and greater than 220 voltage, or any voltage that you are using in your country, just multiply it by root 2, and root 2 is 1.414, and get it as your amplitude and insert it here and press OK. So I want to be sure that this is actually what I'm looking for. This will actually give me 220 voltage. What I'm going to be doing is use a multimeter, AC multimeter, to what, to check the output of this component, if it will actually give me 220 voltage. So what I'm going to be doing is come right here. Okay, we have this is what, virtual instruments mode, no, generator mode, no. So we come right here and we have what, AC voltmeter. So I'm going to put in, I'll put this one right here. Okay, connect it together, and what, so this is actually AC volts, which means this is actually AC multimeter. So I'll play it right here and see if it gives us 220 voltage. Okay, wait a minute. Okay, we have 220 voltage, which is perfect. which is perfect. This is a 220 volts AC, so it is perfect. Okay, this circuit that we are doing today, which is analog to digital converter, has many ways of doing it. If you go online, go to YouTube, go to Google, you see many circuits on this same analog to digital converter circuit. But trust me, I've tried many of these circuits and they are not working just fine until I developed my own way of doing it. So I'll be showing to you guys how I made mine, and it is very inexpensive and less bulky. It is not bulky, it is not big at all. The common way of doing analog to digital converter circuit is using the transformer. After the transformer, you use the rectifier, then you filter it with the capacitor, and boom, you have your analog to digital converter circuit for anything you want to use it for. You stabilize or by using Zener diode or anything. But it is expensive. That way of doing it is very expensive, one, and the second one, it is very bulky. It is very bulky. It is too bulky. But I am going to be showing the simplest way of doing this. But the only problem that this one has is that it can hurt you because you are dealing with high voltage here. It is not isolated. It can do worse thing to you. So you have to be careful if you are making this kind of circuit. You have to isolate yourself and be sure that you won't have any mishandling of this circuit. So okay, the second thing we are going to be doing is using the bridge rectifier to rectify this voltage to convert it to DC voltage. Okay, and what I'll be doing is go here and go for our bridge rectifier. Just pick and write bridge, okay, rectifier. So we have a list of bridge rectifiers here. We have a list of them, but I'm not certain this is actually what I'm looking for. I don't use bridge rectifier actually. This is what I do. I use 4 diodes to make my own bridge rectifier because I want to be sure it can actually tolerate what I'm using it for. Okay, these bridge rectifiers, we have 300 volts, 600 volts, blah blah. This one is actually okay for what we want to do. This one is okay, 900 volts, but this is what I'm going to be doing. I will use 1M4007, 4 of it to make my bridge rectifier. 1M4007. Okay, we have 1 kV, which means 1000 voltage, 1000 voltage and 1 amps current. This is perfect for what I want. If I'm using 1M4001, you can see we have 50 volts, which means if you use this for your rectification, you definitely burn it out because this is not capable of handling more than 50 voltage, and we need more than 50 voltage. That's why I go for 1M4007, which is actually 1000, which is 1 kV, which means 1000 voltage. So this one will be okay. So I'll press OK, then connect 4 of them to make my bridge rectifier. Okay, so this joint, it's this right here, right here. Okay, so I'm going to connect this one with it. Sorry. Alright, these are what we need, and some of you might be asking why we need a bridge rectifier. Actually, bridge rectifier only allows only the positive part of the AC voltage or current to pass, and that's why I use bridge rectifier. Bridge rectifier will allow the positive part of the AC voltage to pass. It will allow the positive part of the AC voltage to pass. If you don't understand what I mean by this, you can let me know and I'll make video on the sinusoidal wave and what I mean by allowing the part of the allowing the AC part of the positive part of the AC to pass. I'm sorry for that. Okay, so that's what we use bridge rectifier for. Okay, to convert AC to DC. But okay, let me put a multimeter here. Since we've converted from AC here to our DC here, okay, so if you want to use a multimeter, you come right here. Sorry, Then we choose our DC voltmeter to check the voltage that is coming out of uh, this bridge rectifier. Okay, what do you expect here? Let's be sure before we simulate. What do we expect here? What's the voltage that we expect here? You should expect voltage that is lesser than this. Okay, than this AC voltage, and I'm going to be simulating it right here. So we have 17 points or 18 points. This is fluctuating. Yeah, it will fluctuate, and that's why I said it allows only the positive parts of the AC voltage to pass while neglecting the negative parts, and here is not fully rectified. And the next thing we are going to be doing is use a component that will stabilize this, that will make it more rectified, and that's what brings us to capacitor. So we are going to be using capacitor to rectify this voltage, and let's be sure of the voltage of the capacitor we want to use. Okay, we are having 220 voltage here. That means we should go for a high voltage capacitor that is capable of handling more than 220 voltage that we are dealing with. So I'll go for 400 volts capacitor. So I have 400 volts capacitor. Okay, this capacitor right here. Okay, this 100 UF 100 volts, this is actually okay. So let me just put it right here. Alright, so join this with this. Alright, before simulating this, I want you guys to note that this voltage here, the voltage here will be times 1.414 of this voltage here. You should note that after rectification and a capacitor, you would have your peak voltage back. Okay, and our peak voltage here, our amplitude here is what, 311. So we should be expecting like 310 here, because bridge rectifier would drop 1 volt. Yeah, this 14007 would drop less than 1 volt or 1 volt. So if you have 311 as our amplitude here, we should be expecting 310 voltage here. Okay, that's how it works. After bridge rectifier and capacitor, we have our peak voltage here, but it will be in what, in DC. So we have it right here. Okay, we have 311 voltage here, which means we have our this amplitude here is 312, I think. Okay, which is 221 times 1.414. You have your amplitude when you get it. Okay, you have when the voltage passes and through this bridge rectifier, we have less than 1 volt. It will depreciate 1 volt from this voltage, and that will give us our amplitude here. So we have 310 coming out of here. This is actually perfect, and you can see we have 310 volt, and it is not fluctuating here. It is not fluctuating. It will fluctuate until this when this voltage here, this AC voltage fluctuates. But if this AC voltage is stable, we have stable DC voltage here, but it is actually too much for what we need. So what are we going to be doing? Is there any other way? Is there any way to reduce this voltage? This is actually too much for the IC that I'm using here. Okay, I'm using the LM358 for comparing my voltage, and 310 voltage is way too much for LM358. So what you are going to be doing right here is try to reduce this voltage to acceptable voltage for our IC, and I feel the highest voltage an IC, or let me say probably LM358 can tolerate is 5 volts. So I will be assuming that 5 volts is actually the highest voltage for my LM358. Sorry for that. 5 volts is actually the highest voltage for my LM358. So what I'm going to be doing right here is make a voltage divider. So when I make a voltage divider, so I will try and reduce the voltage, this 310 voltage, to a smaller DC voltage with a voltage divider, and this is what I'm going to be doing with this. I will consider 320 voltage amplitude. Let me just write 320 voltage, and let me see the output right here. 320 voltage. No, let me just write 342. I think 342 voltage is in amplitude is 300 voltage. Let me see. Yeah, it should be 300 voltage. No, 242. Sorry. I think no 424. I think 424. 424. Okay, we have 300 voltage here. So 300 voltage times 1.14 will give us 423 or 424. Okay. So I assume that 300 voltage is actually too much, and what do? I want this 300 voltage to provide 5 volts here, which means 5 volts here will be relative to what 300 voltage. Do you get what I'm saying? Okay, I assume that 300 voltage, I'm saying it again, I assume that 300 voltage is actually what is actually my highest voltage. Is too much for me, and I want any voltage that is greater than 300 voltage. From 300 voltage upward, I want this here, I want it to give me what, I want it to give me 5 volts, so that it will not burn my IC out, it will not burn it out. So that's what I'm going to be doing right here. And the first thing I'm going to be doing is reduce this voltage. It's actually too much, and I'll go for voltage divider. So let me go for 270k resistor, 270k resistor, 270k resistor, 270k resistor. Okay, 0.6 is what? Okay, we have 270k resistor, and yeah, we have this one is connected with this one is connected with this one, and we have this one to be ground. So our ground is, it's important you ground your circuits, so that proteus will not be confused. Alright, so we have 270k here, so I'll put 3.3k here and see the voltage 3.3k resistor. Okay, let me just use a voltmeter, this voltmeter, and see. Alright, so we have 5.10 at 300 volts. 5.10 is actually 5 volts. So any 5.10, we can say it is 5 volts. It is 5 volts, because in real life you have less than this 5.10, or probably you have 5.15 or anything like that. This is actually perfect for what you want. Okay, so at 300 volts I have 5 volts here. So let me say at 320 volts, what do I have? Let me say at 500 volts amplitude. So what do I have here? Yeah, this is 6 volts, and this is way too much. It is very much for my IC. My IC cannot tolerate this, so I have to stabilize this. And this time, when it's more than 300 voltage, my IC, my circuit will understand that it is more than 300 voltage, and I need a component that will stabilize this voltage for me at 5 volts, and that's what I'm going to be doing here. So any voltage that is greater than 300 voltage, my output will be what? Will be 5 volts, which means 400 voltage, 500 voltage will 5 volts DC will represent higher voltage. Do you understand? I feel you guys should understand what I'm saying right here. But if you don't understand, let me know in the comment section below, and I will make video on that separately. I will understand, I will explain better on that. Okay, but I hope you guys should understand. So I'm going to be using 1M4733A as my Zener diode. Zener diode will stabilize the voltage when it reaches the Zener voltage. Okay, when the input voltage reaches the Zener voltage. Okay, so I have 5.1 volts, 49 milliampere Zener diode, and this is okay for me. So to use it Zener diode, okay, no one actually uses a Zener diode like this. So to use a Zener diode, you have to limit the current that is entering this Zener diode so that it will not damage it. It will not damage it. So I will come right here and use a resistor to limit the Zener and the current that is entering my Zener diode. So I'll use 1k, or you can use 10k, 4.7k, any resistor that you want to use. But make sure in these if you are building this kind of circuit, you should make sure it's more than 1k, is more than ohms. Like you start from 1k, 2k, or any resistor like that. So I'm using 1k right here. Okay, okay, I'm using 1k right here. And so let me just use my 3 voltmeter here. Okay, this is my circuit, this is my output. So I'll be measuring this output for you guys to see what I'm saying. Okay, right here we have a 355 voltage here. So the equivalent DC voltage is 5.25, which is actually too much for my IC. I assume that this 5.25 is actually too much for my IC. If you are using any IC, you go online and look for the data sheet and see the properties, its tolerance and everything like that. But I assume the 5 volts is actually too much. Okay, for any IC that I want to be using, if you are using it with Arduino or anything, if you are using Arduino, 5 volts is with 5.25 volts is too much. It's too much, but it can work with it. Or it's too much. 5 volts is the maximum voltage that you can input into your Arduino. So this is 5.25 volts, and I use my Zener diode to stabilize it to 5 volts here, which means even if you have more than 355 voltage here, even if you have more than 355 voltage here, 600 volts. Okay, even if you have more than 355 volts, okay, we have 425 voltage here. Okay, 426 voltage multiplied by 1.114 will give us this voltage, which is 598 voltage. So after this voltage divider, we have 5.55 voltage, which is equivalent to what 426 voltage AC. So this is way too much for my IC, I assumed. So what do I need to protect my IC from damaging? So I have to stabilize this voltage to 5 volts. So I use a Zener diode to stabilize it, and I have 5.04 voltage, which is actually 5 voltage. So this is okay for my IC. This is good for my IC. It won't damage it, it won't hurt it, and this voltage is actually okay. So I can conclude that this 5.04 voltage is what equivalent to what 426 voltage and above. If I have more than 426 voltage, 500, 600 voltage, this Zener diode here will do well by what? By stabilizing the voltage to 5 voltage. Okay, do we understand this circuit? I hope we understand. So if you have less than 300 voltage, so we have our voltage correctly there. Okay, let me see, we have a 4, no, let me see, we have 311, that's 220 voltage, I think. Yeah, 311 is 220 voltage. Okay, I have 220 voltage here, and if you can see here, we have 3.74. At the same time, you have 3.74 here voltage here. So 3.74 voltage DC is what equivalent to 221 voltage AC. Do we get? I hope we understand this better. But if this voltage rises beyond 300 voltage, sorry, if it rises beyond 300 voltage, definitely we have 5 volts here, which means that 5 volts signifies that okay, this voltage is actually much than the normal voltage. Do we understand? So that it's not what damage our IC. So the work of this Zener diode is first to stabilize the voltage, and two, to protect our IC from damaging or any other microcontroller that I want to use. I hope you guys understand this tutorial, and some of us might be thinking, why do we need this circuit? Actually, if you are dealing with power electronics, this circuit is way needful. Yeah, we actually need this circuit. Okay, if you are dealing with power electronics, power embedded pro systems, anything you want to measure voltage, you want to do multimeter, AC multimeter, we need this circuit. we need the circuit. Okay, this is the art of this project that I recently finished. This is what I used, and next time we'll be doing the practical example, and the next video we'll be making after this practical example video, it will be on the comparators and how we can manipulate this. We have used this project. I will explain that in details too. I will document it very well in a video that I make next. Sorry. Thank you for watching videos. I want you guys to subscribe to my YouTube channel to keep this contents coming in. Thank you once again. Enjoy your day.